Okay, in this section for integration, we are making use of the definite integral that you have learned previously to calculate area under the graph. So there are two big categories of question. The first category is what I'll call vertical area. So for vertical area, we are making use of the x coordinate to find the vertical area under the graph. So I need to emphasize on what is the idea about area under the graph. Okay, so which a lot of people will miss out. If you miss the main idea, you find that you couldn't understand or try out a lot of the area under graph question. Okay, so I'm going to show you the idea first. So this whole page will summarize the main concept for area under graph. Okay, the first thing you will need to understand is if you are exploring vertical area. So what do I mean by vertical area? And what do I mean by we make use of the x coordinate? So it's something like this. Like this is a vertical wall. Okay, and then another one here, another vertical wall. So when we say area under graph, they are usually bounded. There will be two walls to block them. And when we say it's under the graph, yes, it's under the graph, but it will be blocked by the x-axis. So it must be blocked by the x-axis. So if I want to calculate this area will be a positive area because it's above the x-axis. So if I want to calculate this area, I will just do the definite integral. And I can get the area. So area under graph means that it is below the graph, but it must be sticking on the x-axis. So the idea about area sticking on the x-axis is very important. Okay, so in another way, if let's say I give you another graph, and I got two vertical walls here. This is also the area under the graph, and it is sticking on the x-axis. So in this case, I expect the area to be negative. So I expect the area to be negative because it's below the x-axis. Okay, well, what do I mean by I expect the area to be negative? Means if let's say you work out the definite integral, you will get a negative value. But we know that area cannot be negative. So in order to counter the negative, okay, you put a bracket with a negative. You put a bracket with a negative, and you will end up getting a positive area. So you must have some expectation of when the area will be positive, when the area will be negative. And if the area is negative and positive, you are advised to calculate them separately. So later on, there will be one example that shows a combination of positive area and negative area. You need to calculate them separately, then you decide what to do with them. Okay. So this is the main thing. The first thing you ask yourself for area under graph is which part is positive area, which part is negative area. If you are making use of the x coordinate, it is like a vertical strip. So can you see the area here is like a vertical strip. So that's why I put an inverted comma. It's what I will call vertical area. So your teacher may not mention the same thing, but what I meant is it's like a vertical wall, okay, or a strip, a vertical strip of area. Okay, so the key thing will be when we say area under graph, it means that it will touch the x-axis. It must be connected to the x-axis. Okay. And then if you can tell positive and negative area, you will be left with thinking, should you be adding the area or should you be subtracting the area? So I'm going to show you in which idea will you be adding the area. So I'm going to give you a straight line. Okay, I'm going to call this GX. Okay, and I'm going to give you a curve. And I'm going to call it FX. Okay, what shaded area am I interested in? So this will be the two vertical wall. Okay, and I'm interested in this area. So this is the area that I'm interested in. So what you need to realize is the area is under, some of the area is under the straight line. Some of the area is under the curve. So because they are under different equation, so you actually got to separate them. So the trick to separate them is to dot the intersection, dot down the intersection. So some students or a lot of students, they usually don't have this instinct. They don't have the idea that you need to look for the intersection and then you dot down, you will get a coordinate. Usually the question will ask you for the point of intersection, which you need to do a simultaneous. So the idea about dotting down the intersection is to create two vertical strips. Then you can see that there will be one strip that is under the red line. One strip is under the red color line. Another strip will be under the green color curve. So the shaded area that you are interested in is a combination of the red and the green area. So if I'm going to do it, I'm just going to add that two area. So how do I get the red area? The red area will be, this will be the two wall of the red area. So it will be KAGX. For the green one, it will be from here to here. So the definite integral is BK FX. And then you add them up. So when you see that the area, the shaded area is under two graphs, okay, then you kind of get two different graphs and then you add them up. Okay, but you need to dot down the intersection. Another thing will be, because if you are faced with a straight line, for example, in this case, my red color is a straight line. So essentially, this one is a trapezium. So instead of differentiation, instead of integration, you could have used the generic formula for trapezium. Okay, so that's what I will usually do. So if it's bounded under a straight line, it forms the trapezium. I'd rather be using a trapezium formula. But of course, you can integrate the straight line as well. Sometimes I can have a triangle for the shaded area. So in that case, I will use half time based on height instead of integrating a straight line. But for integrating curve, for area under curve, you got no choice. You've got to go for integration. Only for area under straight line, then it's possible that it's part of the shape that you have learned. Then you can use the trapezium formula or triangle formula. Okay, so this is a scenario where you add two pieces of area because the area is under two different graphs. Okay, another scenario, when will you be subtracting? You will be subtracting when you see things like this. So the shaded area will be here. So the shaded area is hanging in the mid-air. So when the shaded area is hanging in the mid-air, again, the first thing you do should be you dot down the intersection. So I'm going to be dotting down the intersection. And usually the question will ask you to find the coordinate of the intersection first. So I will dot down the intersection. Usually after your simultaneous, you will be able to find the intersection point. Okay, then I got to apply my theory of area under graph. Okay, the area under the straight line is a trapezium. So this is the red color. So if I want to get the red color, I can either use integration. I integrate the straight line. In this case, I will get a trapezium. Okay, so you can integrate the straight line or you can use a trapezium formula. It's your choice. Personally, I prefer to use a trapezium formula. With coordinates, you will be able to do that. Okay, then let's look at the area under the curve. So under the green curve, okay, remember just now I mentioned the theory of under the curve is it will touch the x-axis. So the green one will be under the graph. So I'm going to do a subtraction. So I'm going to do a subtraction on the curve, area under the curve. So the shaded area will be the trapezium, the red color, subtracting the green color. So when do you subtract? You subtract when the shaded area is floating in the mid-air. Okay, and when you add up, that's because you see that the area is under two different equations. So generally, you are either adding up area or you're subtracting area. So when your approach should be, think about positive and negative area. Okay, you got to find them separately. After you think about positive area and negative area, you think about, are you going to add the area or are you going to subtract the area? So this will be the main guideline for you to plan. Or else, most of you will be, a lot of students will be, how do I even do that? Okay, so these are the guiding questions. Which part of the area is positive? Which part is negative? So if I'm using the x coordinate, above the x-axis is positive area, below the x-axis is negative area. And then you think about adding or subtraction. So that will be the basic concept that you need to know for area under the curve for using x coordinate.